about that. So again, just in summary, bitemporal data can be a solution to many common data issues. Bitemporal data has a complete history of what you knew and when you knew it. A history, this is the simplest way, I can relate to it. It's a history of how history from a business perspective was stored in the database. If you give it an input of transaction time equals now, okay, bitemporal data gives you results which are as accurate as possible, right? It'll give you the most accurate data it can. Just tell it transaction time equals now, okay? If you give it a transaction time in the past, bitemporal data will give you results which are reproducible, right? As long as you give it the transaction time when you ran, that report, straightforward. Other advantages, that we have, all your temporal requirements are met, right? Boom. One technique, not, 7 different, menu of different accurate or stable data, right? You don't need to, to choose between the two of them now. Truth in advertising slide, right? I don't want to paint the overly rosy, picture here, and then, you find out later. So, there are read and write performance considerations that need to be taken into account. Typically, queries constrain on a date range for every table in the query. Okay, so, truth in advertising. Inserts, updates, and deletes typically go through a layer, especially for that 4 timestamp approach that I was talking about. Increased disk space. There could be a risk of corruption and integrity issues because you have an algorithm populating your data, right? So anytime you're dependent upon an algorithm populating your data, there's always integrity, things to think about. But again, why it's so important that this functionality be built into a DBMS engine. Additional complexity. I think the data modeling isn't that complex. I just think it's new, so it's a new thing. So I think once it gets sorted, it won't be such a big deal. The DML layer is complexity. There are these concepts of temporal entity integrity. There's the concept of temporal referential integrity. Okay, so you can start wrapping your head around the idea that child rows, okay, when you relate them to a parent row, you need to make sure that the parent row is in the same valid period as the child rows, and they can be, different segments. So it isn't just like, one can be in one time period, the other one can be in a bunch of smaller time periods, so you have to compare them all, okay, just to give you a feel for that topic. Schema evolution using bitemporal data can have additional levels of complexity. Derived columns, queries can be, more complex, maybe just because there's more types of them, and architectural complexity. So I don't want to paint an overly rosy picture. But the good news is that things are changing on the bitemporal front. Just in general, the performance improvements that we have, in processing and disk storage and everything helps. Just overall makes more things possible. There's going to be bigger appreciation, acceptance, and adoption. The appreciation, regulators are beginning to catch on to this. Risk managers are beginning to catch on to this, that this is available and important. Acceptance, temporal extensions to ANSI SQL have been approved, but they are not yet published. It's going to be part of the SQL standard, right? So I'm not out here on a limb here, talking about bitemporal data. I think that gives it some legitimacy there. And DBMS vendors are integrating this functionality into their products. Oracle Workspace Manager, anybody who has Oracle, you have Oracle Workspace Manager, comes with it, okay? Pretty high functioning bitemporal solution, okay? People don't use it that much, except maybe for geospatial, types of applications. Pretty high functioning. The downside of it is it's all outside the DBMS engine, right? So, performance is kind of an issue with it. Oracle flashback queries, they just do the transaction time dimension. They don't do the valid time dimension. So I get people ask me a lot about that, and it's, it's not fully bitemporal, but it is good on the transaction dimension of time. IBM's DB2, IBM is really the farthest along in implementing the new syntax. So their version 10 of their DB2 product, like if you really want to get a feel for the syntax, go look up on the web the IBM DB2 10 syntax, and you'll see their syntax is that's the closest thing you're going to find to a description of the new standard is by going there. And Alec and I and Melissa here were taking up the cause of temporal extensions for Microsoft. So I did find out there on Connect that there is an existing suggestion, right? So if you go to Connect and you find SQL temporal, I added a comment on there today, and I was vote number 12. So you can go out there tomorrow and add your vote if you think this is important.
I think you should attach a video to it.
Yeah, that's good. Yes, there you go. Well, so let's see. It's at 12 now, right? Let's spread the word. Let's see if we can get it up to 30 or 40. What is it going to take to get some attention?
good
right?
Oracle.
Yeah, it sounds like fun. And so, critical mass. The SQL standard gives it legitimacy. The DBMS integration gives it practicality, because you can make the argument, believe me, I've written those time slicing algorithms, and people do this themselves in custom code today. You can almost view it as it's almost an enabler to have it integrated into the DBMS engine. I really don't recommend to people to do it, outside, by themselves, except in isolated, kind of circumstances, and mainly then I would recommend using the 3 timestamp approach. But again, critical mass. Well, so another point in the line is, you guys saw the topic for today and you came, right? So hopefully, this is another point on the line that there's enough interest here. And if you all vote up, that suggestion, that will be more evidence that I convinced you. Actions to take. Education. I just think in general, people should get more educated about bitemporal data and the temporal extensions that are being proposed. And again, one good way to, you can Google around, or you can look at, DB2 does have the closest, syntax. I also forget Teradata. In their 1310 release, which I think was like last summer, they have temporal extensions, but they kind of jumped the gun on the standard. So their syntax is different than what the standard's going to be. So it's going to be interesting how they're going to come in line with that, or what they're going to do. Evaluating these products. I recently participated in a project where we invited all the major DBMS vendors in. And and a lot of niche vendors like XML databases and time series database vendors, and put them through a bunch of rigorous tests to you can guess what some of them were like by my example there, right? Here's 5 simple events, store them, put these queries out, but they were much more intense than that. They tested things like temporal referential integrity, temporal entity integrity, schema evolution, all types of scenarios like that. And it was a tremendously, educational project to go through to see where the different, vendors were at this point with their level of support. So that's a great project. Probably not something for small companies to do, but if you work for a bigger company and you can get the that kind of response, from the this was for a bigger company that kind of had the clout with the vendors, so we were able to get them to do that. It can be a really, really educational project to do. Proof of concept. If you do evaluations, next thing, proof of concept. There's no substitute, obviously, for using your use cases, your data, at some point before you jump in further, and then jump into to real projects. The last, thing here is, which I think is so important, is that, why a lot of the reasons that bitemporal is kind of taken so long is that people have been afraid of it because of the complexity and because of the performance concerns. Again, my answer is always, don't give me this subjective, I want to see where is the performance hit, under what, scenarios. And I think the way that this is going to happen, is by having some standard benchmarks. Right? Some standard functional and standard performance benchmarks put out there for people to know, that if they have this type of volume and these type of performance requirements, is it going to be an issue or not? Right? It's been one of the biggest concerns. And so, I really think that supporting, any kind of efforts like that are going on is an important thing. And so obviously in the next slide, I'm going to tell you specifically where you can do that. Well, after the summary, I'm sorry. So, wow, we might make it. So in summary, there are 4 major types of temporality. These 4 types of temporality have clear data stability and support for correction characteristics. Physical storage options can be understood by the type of temporal support they have, right? So if you have a physical storage option, which is valid temporal, and if you understand valid temporal characteristics, guess what? That physical storage option is going to have those characteristics. Requirements are met by these physical storage options. Architecture is kind of deciding which physical storage options to use and how to use them. Many common database design techniques we use today have shortcomings, and bitemporal data is a solution to many of these common data issues. But again, truth in advertising, it is still the early days. There still are some costs and risks associated with it, but things are changing on the bitemporal data front, with the new SQL standard and DBMS vendor integration. So if you want to find out more about bitemporal data or temporal data or the types of things covered in this presentation, there's a website, temporaldata.com, which is hosted by who you can probably guess. There's a LinkedIn group called Temporal Data, and there's a pretty rich group of people there, from Hugh Darwin, who wrote all the books with C.J. Date, to Richard Snodgrass, who's kind of the academic father, of all this stuff. All the major DBMS vendors have the guys working on their SQL engines are in this group, including Microsoft. There must be like 5 people who work on the core Microsoft SQL Server engine who are part of the group. A lot of people are kind of quiet. You know, I don't think they're kind of seeing what each other's cards are, you know, and stuff. But there's enough consultants out there to yap things up, you know, to keep it interesting. And then lastly, this Stack Research is an organization that I'm involved with. They do low latency trading benchmarking, you know, is what their, you know, kind of forte is. So, you know, they have been really successful in establishing benchmarks for low latency trading. And so I approached them about trying to do the same thing for bitemporal data, and we've got some really good traction. We just had meetings in London and in New York, had really great attendance. So if you're interested, you know, in this functional and performance benchmarking and getting involved with that, you can just go to that link there, stackresearch.com/BTD, and get involved there. I think it's going to really, you know, hopefully be an enabler for, you know, more adoption of this technology. Thank you.
Cool.
All right.
Thank you.
All right.
Do we have questions?
Go
I have
ahead.
questions.
Okay.